Hey everyone, we are looking at the integral of the reciprocal function. So before we jump into that though, just a reminder. So remember this way back when the derivative of natural log x is 1 over x. And if you have something fancier with something besides an x, we have to chain rule that, right? So we're looking at reversing this. So we're talking about having something that looks like this. The integral of 1 over u du equals, and since we're going backwards, it's going to be natural log. The absolute value is there because, like, if we throw something in here, it needs to be positive. You can't take the natural log of a negative. If you remember looking at your graph of y equals natural log x, you would see the domain is x is positive. So no taking natural logs of negatives. So those absolute values pop in. So really what you're looking at in terms of the form, I'm making this really official math conversation here. If you have a fraction, you had in an integral, you had better hope it's in this form. You have stuff in the denominator and the derivative of said stuff in the numerator. And if you do have it looking like that, your integral is natural log absolute value of that stuff, the denominator, plus c, of course. So let's look at a few examples. So if we have something like this, we have 3x squared over 2 plus x cubed. Let's go, oh, it's a fraction. Is the numerator the derivative of the denominator? Well, the derivative of the denominator is 3x squared, so yes. Great. We're basically done here. Natural log absolute value 2 plus x cubed and then plus c. Okay, that was a straightforward one. And now let's make it slightly less straightforward. Looking at this guy, x to the 4th over 5 minus x to the 5th, the derivative of the denominator is negative 5x to the 4th. I really want to have a negative 5 here. And I can have a negative 5 here if I throw a negative 1/5 out in front. Because by multiplying by both of those, I haven't actually changed things. It's just a little bit of a rearrangement. So we get negative 1/5 times natural log absolute value of that denominator, 5 minus x to the 5th, plus c. Straightforward-ish, I suppose. Okay, one more example, then we're done with this first round of our videos. So looking at this, we have cosecant squared 3x over cotangent 3x dx, and is the numerator the derivative of the denominator? So close. We know it needs to be negative. We also know, because of the chain rule, that the derivative of the inside has a times 3. So I really want a negative 3 here. Well, same as before. I can throw a negative 3 there if I throw a negative 1/3 out in front. So I have negative 1/3 natural log absolute value cotangent 3x and plus c. So again, anytime you're looking at a integral and you have a fraction, cross your fingers and hope that the numerator is the derivative of the denominator. And if it is, you're good to go. You might have to adjust a little bit like here, but not too bad.